Okay, just to finish off electrical power 5.3, where we'd got up to was we said that power equals voltage times current. Okay. And we said that voltage also equaled current times resistance, which means that power equals, so if I just put V I P V I R, so the power equals IB, which is the same as saying I times R times I, which is the same as saying I squared R. Okay, so, and the reason why this is interesting is because if you remember we said on the national grid you have step-up transformers that increase the voltage and decrease the current, and this is why, because if I double the current, then the power loss, so the power that will be used up going through those cables, won't just be twice as much, it will be 2 squared as much, so it will equal 4 times as much power used. Okay, so that'll be 4 times the amount of energy every second, and that's why you have step-up transformers to reduce the current, because the current squared is how much power is being used up. Okay, go back to the last lesson if you're not sure where the VI came from, because that's the bit which we finished on last lesson. Okay, so next thing is we need to know how to choose a fuse. So now that we know all these things about how power and current are related, we need to choose a fuse. And fuses come in 3 flavours: 3 amps, 5 amps, or 13 amps. Let's say that I've got a circuit which has I have a component in a circuit which has a power rating of 27 watts, and it's plugged into a battery that is using 9 volts. Okay, so that means that the fuse that I would want is going to be P equals IB. So my power is 27, my voltage is 9, which means that the current that I want to go through it is 9 equals 3 amps. So I'm going to pick my 3 amp fuse. Now the key thing is, if the voltage was slightly higher, then this would be less, and if it was slightly lower, and if the power was higher, then the amount of current you need would be more. So things like kettles, electric heaters, they use the big 13 amp fuses. Electrical appliances, they use much smaller, especially computers type equipment, they use much smaller fuses because they have much smaller currents going through them. Okay, and the idea behind the fuse is that when you have your fuse in the circuit, it heats up, and when it heats up, it melts, and when it melts, the circuit's broken, and that protects the other equipment from getting damaged. So if you put a 13 amp fuse into this one, the problem with that is it could take way too much current before the fuse would melt, and then what would happen is that the component would get damaged before the fuse melted. So that's why you've got to make sure you pick the right fuse, and the equation that lets you pick the right fuse is current times voltage. So whatever the power rating of the equipment is, equals the voltage that you're going to put through it, and what's the maximum current then you really want it to have, and then pick a fuse that's got slightly more, that allows only slightly more current than this.